So welcome in everybody, good evening. Again, I'm Coach Anderson. This class is gonna be recorded and at some point throughout the weekend or next week, we'll post this. But for those of you guys who are in the All-Access program for my ASVAB classes, this is gonna be up first thing tomorrow morning once you log into the course. So with that, let's go ahead and get started here. We're doing solving equations today, my party people. So two things that we're gonna be learning are, well, one, how to solve equations, how to solve them the right way really every time. And then number two, we're going to be tackling those more complicated equations, the ones that take more than 2 steps, or you might have to notice something about the problem to get it done a lot faster. So with those two things in mind, remember that we're never here to try to memorize questions. We're here to understand the process. So for example, for those of you that are here, again, welcome in everybody, but I got a quick question. Has anyone here ever tried to memorize a question from a practice test, hoping that it would be on the actual test? Has anyone here ever tried to do that? Taking a practice test, try to memorize a couple of them, be like, whew, baby Jesus, hope they're on there, right? A lot of people do. And I see that about a little more than half of you guys said yes. And so that's something I want to caution you against. Whether you have been doing it or are still doing it, remember that it's not about memorizing the numbers. It's about understanding what they mean and understanding the process in terms of how to solve these problems. So let's get away from that, okay? We're not memorizing steps, we're understanding steps. So here we go. For those of you that are in the program, so give me a quick yes or no. Are you in my full program? Yes or no? What's up, Jacita? Glad you're here. All right, cool. So that should be the majority of us in here, and welcome to those who got invited for free. But yeah, so for those of you that are in the program, I want to show you how to find the new practice that we're going to be uploading into the courses. So if you weren't here for this last week, remember, I'm going to be updating the math bootcamp throughout this entire summer. I've already started last month. And what I'm doing for every single topic is we're going to create guided practice videos where I take you through practice problems from that specific topic. Then number 2, provide you with worksheet problems or drill sets. And then number 3, provide you with speed drills. So if you weren't here last week when I talked about it, basically a speed drill is you have an unlimited set of questions. You can reset it as many times as you want to, and basically you'll be able to practice that specific topic over and over and over again, being timed so you can feel that pressure. That way, when you do the real test, it's not like it's unfamiliar to you and you freak out and you freeze up. It's more like, nah, I've been here before, I know exactly how to handle this and I'm fine. So with that being said, I just want to prove a point in terms of why I'm doing this. Everybody, yes or no, do you sometimes feel like the pressure of the test of being timed sometimes makes you do worse? Okay, cool. So that's, again, you look at the chat box, this is why I do what I do. I want to make sure you guys have every single tool that's really needed to ensure that you are simulating the actual test environment. So with that said, I'm going to go ahead and show you guys a quick little preview of these updates in the Math Bootcamp. So when you're in the Math Bootcamp, so there's my face, that's the program I use to do this stuff. But here, when you're in the program, you can go to the course, the Math Bootcamp course. Remember, the Math Bootcamp course is one of the many courses you got when you got the program. It's not just about the classes, but about the practice you get in between the classes. So over here in the Math Bootcamp, you can watch how to use it there, but I got to redo it since I'm adding so much right now. But if you go to the fraction section, last week, what I uploaded was a guided practice section or a video right over here, literally going through every single type of problem for simplifying fractions. And then after that, my party people, you go through that, then you go through the worksheet and you practice yourself. You got over 100 problems on some of these worksheets. Every worksheet has a minimum of 65 problems. Then from there, you can go to the speed drill. And this is where, again, you practice for speed. So you notice that you're being timed here at the top right. And then you see that it tells you what the topic is. And then from here, you pick your answer and you keep going. And you try to answer all 10 questions before that timer's up. Nice and easy. Then when you're done, you hit submit and it tells you how many you got right, how many you got wrong. And you can even look at your answers and see which ones it were that, yeah, you need help on. And so this week, what we're doing is the same thing for solving equations. So this one was a little harder to do. That's why it took us a little longer. But check this out, my party people. This is what we're working on. First, you're going to have solving equations one step. So this is what we're going to be reviewing today. So you're going to see that what you've got, let me go ahead and let these people in the waiting room. What you're going to see is you'll be able to go ahead and practice and practice and practice and practice and practice and practice. So that was question 100. Let me retake it. And like, look, you have literally a bank of 100 questions that you're going to be able to practice with over and over and over again. And then we just got done with 2 steps right over here. So here we have 2-step equations, and then we're going to be adding multi-step equations, systems of equations, inequalities, all of it. It's all coming in. That way you have videos for it, worksheets for it, and time practice. So with that said, everybody, yes or no, does that make sense? And give me a few words if that excites you. Yeah, it's going to be about 100 questions for each of those little ideas. So 1-step equations, 100 problems. 2-step equations, 100 problems. Multi-step equations, 100 problems. Inequalities, single-step, multi-step, everything. Yeah. So that's what we've been working on in the shadows. And so if you guys have seen that I haven't been replying as quickly as I used to be, it's because I'm making sure that this is like the bomb.com for you, all right? So with that said, let's go ahead and stop sharing the screen here, bring this back, and let's keep it going. This is the main piece of notes that you're gonna really need to take. But remember this, everybody. Your notes are there to guide you. You know, a lot of the times people think that notes are just there to write down in some cases. And in other cases, I've seen a lot of students take notes and never really get away from using them. Remember that your notes are there as kind of like training wheels on a tricycle or on a bike, excuse me. You know, once you're good enough on your own, it's time to take those training wheels off because you understand how this all works. So let's go ahead and take these notes down, take a picture if you need to. But these 4 steps, again, it's more like a guiding book and not supposed to be something that you rely on forever. So write that down. I'll give you about 1 minute, minute and a half here, but let me just kind of walk you through the 4 steps here. So when it comes to solving equations by party people, look, if you can simplify before you start anything, it's a good idea to do that. That's what step number 1 is. We'll have some examples later on in the class of what that looks like. But in the beginning of class, we're going to start off with those 1-step equations that are pretty straightforward. And then we'll move up from there. Number 2, what we need to look forward to doing is making sure that we move all parts of the equation that have variables or letters, move those to one side. Everything that has a number, move it to the other. And that's it. So once you focus on that, getting all the variables together and then getting all the regular numbers together, that's step 3. That's where you're going to isolate that by working backwards, whether it's multiplication or division or square roots or whatever it might be. We'll take every problem one by one. We're all good, but we're going to go ahead and work backwards to solve. And then at the end, if, you know, in the beginning, we do definitely want to check our work, and we will be doing that. And so for those of us here that are ready to party, how do we check our work after we solve an equation? How do we check our work once we solve an equation? Right, we're plugging it back in. Right, we are plugging it back in. Now, for the person who just asked, I didn't catch your name, but for the person that just asked, what do I mean by working backwards? Well, what I mean by working backwards is this. Everybody, yes or no, have you ever heard of the order of operations? PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. Right? We've heard of it. Sounds good. So really what I'm talking about when I'm saying working backwards, I'm talking about working backwards from the order of operations. I'm going to show you exactly what I mean when we get to a couple of examples. But for right now, that's exactly what I mean. We're working backwards from the order of operations. So let's go ahead and move forward here. One thing we got to get around on the test. Is it possible to have fractions inside of equations? Yes. Is it possible to have decimals inside of equations? Yes. You know, is it possible to have negative numbers? Yes. You know, that's something that I need to repeat every single time because my party people, look, everybody, are you 100,000% confident with fractions, decimals, and negative numbers? All 3 of those, yes or no? Are you 100%, 1,000% confident? Okay, so I don't think I've seen a solid 100% yes yet. Okay, so with that said, this is something you need to understand. Negative numbers, just numbers. Fractions, just numbers. Decimals, just numbers. There's certain rules that they follow. There are certain rules that they follow, but at the end of the day, they are just numbers. They're different types of numbers. And I know a lot of us are used to just dealing with those pretty numbers, but look, they're just numbers. Learn those rules. That way, when they pop up in all of the different topics, like proportions, equations, geometry, whatever it is, you're good to go. You don't want to put yourself in a position to fail just because you didn't do your practice. Okay. So with that, let's go ahead and take some notes here. So I don't know why that page went missing, but let's go ahead and write this down, everybody. And for those of you in the program, you know what I'm going to say. Everybody, solving equations is the art of what? And please excuse my handwriting. It's probably poor, but whatever. So solving equations is the art of what? What is it? That's right. For those of you in the program, it is going to be working backwards. And so I want everybody to know this. When you're solving equations, you are working backwards, okay? Art of working backwards. And what I'm going to put in the parentheses, so this is new for everybody, including those in my program. Solving equations is the art of working backwards. And in parentheses, I'm going to write from the order of operations. From the order of operations. Okay, that's what solving equations is all about. And so just keep that thought right there in your head. You know, you might be asking, you know, what do you mean backwards order of operations? I got you. I got you. So I'm going to give you just a few more seconds here to kind of write that down, and then we are going to move forward here. All right, so let's go ahead and get into it here. Let's take a look at some of these examples. So let me just kind of zoom in on number one. Actually, let me go ahead and write a different one down. That way we don't get any sort of confusion in terms of what I'm about to say. So let's say x plus 5 equals 7. Okay. Hey, hope you're enjoying the session recording so far. So as always, if you're looking for extra ASVAB help and support from a coach to kind of guide you through the process, study planning, and all the materials you need, just shoot me a text real quick. Again, I'm Coach Anderson, 567-698-8867. Go ahead and ask me about my All-Access program, or just ask me about the program in general. I'll be more than happy to tell you about it so you know that you can stress less and raise your score with ease. Again, I'm Coach Anderson. Let's ace the ASVAB. Text me now, and then let's keep going. Let's go ahead and start with this very, 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 very straightforward example. So everybody, when you're solving an equation, when you're looking at a variable, in this case, x, is x known right now or not known? Like, is it known or unknown? Right, it's not known, it's unknown, right? You don't know what it is. But let's for a moment pretend that we did know what it was, okay? Let's for a moment pretend that we did know what it was. And what I'm going to do is I'm going to pretend that x is 2. I'm going to pretend that x is 2. So I'm going to plug this in right here. I'm going to say, 2 plus 5 equals 7. Okay? Everybody, is that a true statement? 2 plus 5 equals 7? I'm hoping everybody says yes. All right, sounds good. All right, so with that, let's take a look at this, really. Like, nice and simply, this is what I mean by working backwards. Everybody here, we know what the 2 is. We know what 2 plus 5 is. And so we move forward and add 2 plus 5 to get that 7. Remember, equals just means that this side and this side, they're the same, okay? They're the same. And so let me go ahead and show you over here. Let's pretend we have that variable now. The 2 isn't there anymore. We know the answer is 2, but check this out now. This is what I mean by working backwards. Everybody, we don't know what x is. You guys have already said that. Now we're saying, something plus 5. If we're moving forward, something plus 5 equals 7. So working backwards means this. If you're saying I start at some place and I add 5, I get here. Well, then to go back to here, I got to go backwards. Everybody, what's the opposite of adding 5? What's the opposite of adding 5? Subtracting 5. Exactly. And so everybody, remember what I just said. An equation right over here means that this side equals this side. This side equals this side. And so everybody, if I'm going to subtract 5 over here, where else might I need to subtract 5 in order to keep things fair? Right, it's going to be under the 7, under the other side. And so have you ever heard anybody say, whatever you do to one side, you got to do to the other. Whatever you do to the one side, you got to do to the other. That's where that comes from. Because remember that equations are basically statements of balance. This and this are the same. So whatever I do over here, I got to do over here to keep that truth equal. So with that said, we subtract 5 on both sides. If you heard that from me, appreciate you. You're welcome. And so with that, you're going to see that 5, if I add 5 and take away 5, that's supposed to cancel out. They're opposite operations. And so what I have over here is x equals 2. And that would be the answer that we got earlier, like we just saw right over there. So with that said, everybody, again, what we're doing right now is going over the basics. Then we're going to keep creeping up into the medium 2-step equations, then those harder multi-step equations, and then wrap it up. But from what we just gathered right now, on a scale of 1 to 10, how much sense does this make so far? When you're solving an equation, you're working backwards. Cool. Sounds good, sounds good, sounds good. So what we're going to do now is we're going to go ahead and tackle these problems that are on this page, going through that reasoning. I'll let you guys practice some on your own. And then from there, we're going to take it to the next level and looking at 2-step equations. Right now, notice this only took 1 step. So coming up here, we're going to practice these 1-step equations, and then we're going to move forward from there. So over here, what I'm going to write, I'm going to give you guys the opportunity to try these out. And what I'm going to write over here is solve by doing the opposite operation to both sides. Opposite operation to both sides. All right, so I'm gonna go ahead and highlight that and give you guys the chance to really try this out. All right, so I'm gonna go ahead and let these folks in. I'm not even gonna set a timer. I'm just gonna give you guys another minute here. And I just want you to try one of these. Just want you to try one. And I want to see if you can actually point out what operation you're doing. That's it. I don't really need you to solve these. I just want you to give a little hunch in your head. What should I do there? I think it looks like I should subtract there. Looks like I should do this there. Just try it out. Just try it out. All right, so let's go ahead and give it a shot here, my party people. Let's go. So over here, let me go ahead and do that. All right, perfect. So there it is. All right, perfect. So here we go. Number 1, we have 6 equals 8 plus x. So, or 8 plus k, excuse me. We're looking at this and we're saying, okay, what's the goal? We're trying to get k by itself. Now, everybody, we're trying to get it by itself on the same side of that equation. What is in the way? What is in the way? What is in the way of us saying that k is by itself? Okay, I think a lot of us, everybody here is saying, yeah, it's the 8. There's absolutely an 8 on that same side. Exactly. There's absolutely that 8 right there that we got to get rid of. So my follow-up question is this then. What's that 8 doing? Is that 8 right now being added, being subtracted, multiplied, divided? Is that a power? What is that? What is currently happening as you see what is happening? Right, it's being added. That 8 is being added, right? And so the question to ask yourself is, yo, I'm trying to get the k by itself. There's just an 8 being added randomly there. How do I work backwards to get rid of the 8? Everybody, what do we do? Exactly, the opposite operation. The 8 was being added, so we're going to work backwards and take it away. And so let's go ahead and be formal here because I got to make sure I get on you guys here. That way you don't make this mistake later on and not get lazy. So what I want everybody to write in the chat box is, we are going to subtract 8 from both sides. Too often I see everybody just say subtract 8, subtract 8. Say subtract 8 on both sides. Start recognizing that formal process now. That way you never kind of freak out and kind of question yourself later on. Subtract 8 on both sides. This is what that'll look like. Right there and there. And then here we'll just do 6 minus 8. And on the right side, the 8 minus 8 cancels out. So we have over here, K equals what? And so 6 minus 8, what is that, everybody? I see a lot of people here are pretty confident with those negatives. I see that. I like that. -2 would be the answer. And for those of us that are hanging back, in your bedroom or in your kitchen, kind of looking back and like saying, 6 minus 8, I don't know about all that. Here's the thing. Really quick, 8 minus 6, that's 2. If you go the other way, 6 minus 8, that's -2. That's it. Whenever you have a positive subtracting a number, just take the difference of the numbers, no matter which way it is, take the difference, and then just keep the sign of the bigger number. Because 6 and 8 are 2 numbers away. You're taking away 8 too much. So that's why it's 2. That's why it's -2, not +2. But with that, let's go ahead and go to number 2 over here. Anybody here looking at this one a little nervous? Is anybody looking at this one a little nervous? I see a lot of no's. I like seeing that, but I do see some yeses. About 1 in every 4 are saying yeah. Okay, cool. So here's the thing, my party people. We're just trying to work backwards. We're trying to get right here, this variable p by itself. And so we just have to ask ourselves, what is currently happening to the p on that side of the equation? Tell me, guys, what's happening? What is happening to the p? Right, it's currently being divided by 11. So again, let's work backwards. If you take that number and divide it by 11 to get 4, well then let's multiply by 11. Let's work backwards. Exactly. So let's write that out, multiply by 11 on both sides. And here's the thing. If you multiply by 11 and divide by 11, you get right back where you started. And so 11 times 4, everybody, is what? Exactly, 44. Nice and easy. Nice and easy. Boom. Nice and easy. So hopefully if you try number 2, there you go. Now let's go ahead and take care of number 3. Number 3, everybody, I'm going to go ahead and give you about 20 seconds here, and I want you to type out in the chat box what you think we should do to both sides to get this done. So go ahead, type it out as you're ready, and let's see if we got it. That's right. Subtract 17 on both sides. That's right. Yep. Because again, 17 is just sitting there. It's being added there. It's just there. So we will work backwards by subtracting that 17, and we're good. And we're good because what happens here, that cancels out. And then we have 4 minus 17. And remember, like I said, when dealing with negatives, just do 4 minus 17 as 17 minus 4. That'll go ahead and end up being 13. And it'll be -13 because you're subtracting the bigger number. So -13 equals X. -13 equals X. And so last one here for the one-steppers. It's going to pop in right over here. 90 equals -5 times B. And so everybody, are we subtracting 5 or is it something else with the B? Are we subtracting 5 or what? What is currently going on? My bad. I'm asking what's currently going on. As you notice it, what's currently happening? Is that -5 being subtracted from the B, added, divided, multiplied? What is it? Right, it's currently being multiplied. So this is something that I want to caution everybody against. Sometimes some folks will see a negative and interpret that as subtraction when it comes to equations. So I want to make sure you see this the right way. Everybody, really quick, if I were to write, let's go ahead and say 15x. Everybody, 15x means that we're multiplying 15 times x, correct? Right, correct, yeah. If we're taking 15 and attaching it to the x, it's implied that we're multiplying. Same thing over here. The -5 and the b, those are being multiplied together. And so I don't want you guys to see that as minus subtracting 5. No, it's -5 times the b. So you write that over here. So there's the b, and then -5 is being multiplied on. So everybody, what's the opposite? What is the backward step of multiplying by -5? What is that backward step? Divide by what though? Yeah, Krista, exactly. That's why you divide. That's why you divide, because you're working backwards. Yep. Yeah. And so what we need to do here is divide by -5. Not +5, -5. And I'll show you why in a moment here. I'll show you why in a moment. The reason we're dividing by -5 is because, everybody, what's a negative divided by a negative? A positive. And we're looking for what b is by itself, not negative b. We're looking for b, positive b. So that's why that'll give us positive b here, because the negatives cancel, and so do the 5s. And so you're just left with the b equals, and then you just got to figure out what 90 divided by -5 is. Everybody, a positive divided by a negative is what? A positive divided by a negative is a negative. And once we perform 15 or 5 into 90, that's going to give you 18. So I'm going to skip the actual long division work because I just used some mental math there. And for those of you that did not know, again, in the math bootcamp, we also have mental math and calculating. We already have that in there. So you can go ahead and practice your mental math all day, every day, especially with the negative numbers as well, especially with the negatives. Toward the end of class, I'll show you how to find that in the math bootcamp as well. So let's take a look at these next 4 problems here, my party people. I'm going to give you the opportunity to try these out. So let me go ahead and get this going right here for you. I'm going to get you a little timer up and running. And I'm going to give us exactly 2 minutes, which gives us about 30 seconds per question. Try this out. Go ahead. Number 5, we have 9 equals n divided by 20. Okay, so n over 20, everybody, the fraction, and I gave it away by saying it, the fraction n over 20, what operation is that again? What operation is that? Yeah, that operation is division, exactly. It's going to be division. We have the n right here, and it's being divided by 20 because it's part of a fraction. So if we're working backwards, we got to go ahead and find a way to break in. We got to break in, and the way that we break in is by doing the backwards or opposite operation. And so with that, everybody, that's going to be multiplication, as you guys just said, and we'll multiply by that 20. So right here, booyah, times 20, times 20. And on the right side, it's going to cancel out. Because again, if you take a number, times 20, then divide by 20, right back where you started, so you're good. And so that's going to be n equals 20 times 9, everybody. Help me out. I'm a little slow today. 20 times 9, 180. Perfect. There we go. And we're good. So number 5, give me a "you're" if you are good. John lies. Maybe, I don't know. I'm still recovering from COVID. So with that, yep, cool. Sounds good. Appreciate that. There we go. There we go. There we go. All right. Number 6, let's take a look here. P minus 16 equals -33. If you had a brain for the number 7, don't worry, I got you. So P minus 16 equals -33. All right, everybody, what is currently happening to that P? Why is it not by itself here? Why is it not by itself here? Right, we see that we're subtracting that 16, right? That's what's in the way. You know, P is not -33. P minus 16 is -33. So if you took away 16, then you would get the -33. So to work backwards and figure out what P is, you got to add 16 to both sides. Now, again, if you're sitting here saying, hey, coach, I knew that that was the step, but is that, I don't know how to do a -33 plus a 16. Like, that's my problem. Well, then you have your answer right there. Practice working with negative numbers. I can't stress it enough. If you don't have your basics down, then learning these new topics always gets harder and harder. especially the further up you go. So over here, negative 33 plus 16, again, is the same thing as saying positive 33 minus 16, just keep the answer negative. Take the difference, keep it negative because the 33 is the bigger number. So 33 minus 16 is going to be 17, and it's going to be a negative 17. B equals negative 17. Right, we're keeping it negative because the 33, the negative 33, that's the bigger number. Remember that adding with negatives or subtracting even, all you're doing is basically seeing how far the numbers are apart. That's all you're saying. And so negative 33 plus 16, those numbers, 33 and 16, if you subtract them regularly, they're 17 apart. You make it a negative 17 because you have negative 33. That 33 is the bigger number. And so you're leaning to the negative side. So with that, again, I'm not doing a sermon here on negative numbers, just trying to hint at this for you guys. I got you. But here, we're good. And so let me provide a little illustration for those of us that are struggling to understand why we're working backwards. So this is a nice little illustration that I want to show you where I draw a perfect rectangle, because you guys know I never messed up on drawing rectangles. And so let's say that we have this. We have P right here in this box, right? Let's say we have P. Everybody, yes or no? To get to that negative 33 that I'm going to draw right over here, to get to this negative 33, right over there, boom. So to get to this negative 33, is it true that we have to go ahead and actually subtract 16 from P? Like take that P, subtract 16, and I get to the negative 33. Is it true? I appreciate you, Gloria. Thank you. Yeah, right. That's what the problem says. The problem says, hey, start with P, subtract 16, and that's how we arrive at that negative 33. For those of you that are not understanding how this is working backwards, like how or why we're working backwards, look, right over here, if you're telling me that to get from here to here, I take away 16, then to go back from the end to the beginning, I got to work backwards. I got to add 16. So does that make a little more sense for those of us that are slightly confused on why we're working backwards? Think of it like a path from start to finish. You start somewhere, you subtract 16, and you get to negative 33. So to work backwards, starting from here, add 16 to get back to where you started. So that's the idea that I really want to help you guys see. And I'm going to show you that with the two-step equations up next. This one might be a little tougher for some people, but it's okay. I got you. So everybody, first and foremost, is that 1 that's over there, that 1 with the minus P equals 9, that 1 right there, is that 1 just sitting there being added, subtracted, multiplied, divided? Is it just sitting there doing what? What is it? Hey, if it had you confused, no worries. If it had you confused, no worries. Orlando, no worries. I'm going to go ahead and let you take a picture right at the end. I got you. Right after the slide. So I see a lot of us are disagreeing here. A lot of us are saying, hey, some of us are saying it's being added. Some of us are saying it's being subtracted. I got y'all though. It's being added. It's being added. If we just write, everybody, if we just wrote, like, let's say 3 plus x equals 10 or whatever, that 3 is just being added, right? It's a positive 3, and then we're adding x. Over here, if I wrote 12 plus y equals whatever, 15, that's just being added. If I wrote 7 minus a equals 8, that 7 is still just being added. It's the variable that you see that got changed to being subtracted. It's the variable, but that is still a 7 there. Over here, that's still just a 1. Everybody, yes or no, does that help you see this a little more clearly before I move to the next step? I want to make sure we understand that, because I understand that this is a huge little like, huh? moment for a lot of people. So I got you here. It's those little things that really matter. Yeah, so again, the conclusion here is that, that one, even though it says minus P, the one itself is positive. It's just a +1. So to get rid of a positive one that's just sitting there, everybody, what do we do to both sides? To get rid of it, we would subtract. So again, yeah, so I got to say this one more time, then we are moving forward here. So just like in these, that 3 is just a +3 chilling there, and then you add x. That's just a +12 chilling there, adding y. This is just a +7 there, except we're just subtracting the a. But the 7 itself, that number in front, you don't see a negative there. That's a +7. There is no negative in front of it. There's a negative here, and that's telling you that you're subtracting the a. But this 7 right there, this 7 is a +7. Over here, this 1 is just chilling. It's a +1. This is subtracting P. That's just a +1 though. You don't see a negative there. And so to get rid of a +1, you would subtract 1 on both sides. Yes or no? Does that make sense? Yes or no? Does that make sense? I got you, Krishan. Cool. So from here, what we're going to do, my party people, is this. Just go through with it. We get a 1, -1. Those are backward steps. Those cancel out. And so what we have over here is minus P or negative P, whichever way you want to say it, equals what? Right on, equals 8. So we have negative P equals 8. So what do we do now? This is a step that we haven't taken care of yet. If we're looking at this, what we were saying is, hey, negative P equals 8. So the negative version, if you take the negative version of P, you get 8. Listen to that again. If I take the negative version of P, I get 8. So everybody, to solve this, should I work backwards and just reverse or flip the signs on both sides? You guys might know that as dividing both sides by -1. It's all good, Krista. Yeah, Ricardo, that's right. Divide by the -1. Everybody, another way to look at this is like this. When you have just the variable, when you have just that variable right there, what number is actually in front? Because sometimes we might see 2x, 5x, 10x, but here we just see P. What number is in front of there? A 1. Exactly, there's just a 1 there. So notice how it's technically speaking, that's -1 times P. So everybody, how do we get rid of the negative or the -1? How do we get rid of it? Instead of multiplying by -1, we should divide by that -1. Exactly. We should divide by that -1. Because if we do that, a negative divided by a negative, that's a positive. That's a positive. And then 8 divided by -1. Well, anything divided by 1 is itself. 8 divided by 1 is 8. But a positive divided by a negative, that's negative. And so that's one way to look at it. Honestly, my party people, the rule is whatever you do to one side, you do to the other. So if I got myself sitting here with negative P equals 8, I'm just going to change the sign on both sides and call it a day. I just changed the sign on both sides. All right, so you're allowed to do that. Again, as long as you do the same thing to both sides, you're good. So that was number 7. I took a little bit more time with that one, obviously, because I want to make sure that we're good there. But let me go ahead and scroll up a little bit here for number 6 as well, for those of you who want to take a screenshot before we go to the last one. Sorry, these are my actual glasses. And if you're going to take a screenshot of me for free, you're at least going to have that face on your screen. So with that, let's go ahead and go to number 8. Let's go to number 8 here. So we have ourselves -2 equals P minus 6. So for those of you who haven't noticed or have noticed, I have a lot of these questions with variables on the right side. A lot of you are too used to seeing those really clean ones where it's on the left. So I did this on purpose. I want to make sure you get used to this from the very get-go. Doesn't matter what side the variable's on. So up next, love the humor. So here, what we're going to be doing is just observing what the variable is and what the backward step needs to be. So we have P just chilling there. And on that same side of the equation, we notice that we're going to be taking away 6. So again, thinking about it, like if we're supposed to take P, subtract 6, and we get -2, well then to work backwards, to go from the -2 back to the P, we got to do the backward steps. So if -6 means take 6 steps back to get back to where we were, take 6 steps forward. And so I'll add 6 to both sides. And you're good to go. And remember, everybody, look, -2 plus 6 is the same thing as saying 6 minus 2. It's the same thing. 6 minus 2 is 4. So we get 4 equals P. Yep, and thank you. Yeah, don't forget to cancel right there. -6 and +6, that cancels out, and that's what gives you that 4. Appreciate you, Mario. Exactly. All right, so if you got -8, that means that you didn't add 6, you might have subtracted 6, because -2 minus 6 would give you the -8, but you need to make sure you do the opposite step here. P minus 6, so you add 6 to cancel that out. Remember, guys, the goal is to get the variable by itself. We want to get the variable by itself. We want to get that P right there all alone. So what was in the way? Taking away 6. To get rid of taking away 6, we add 6. That's like saying your little cousin came into the room and grabbed, let's say, 6 quarters that were on your desk. And then to make up for it, he needs to put back 6 quarters to have the original amount. Right here. P, if you took away 6, well, to get back to whatever you had, you got to add 6. And that's how you get back to it by itself. But you got to do it to both sides, remember, because again, they're both supposed to be the same. So if you do this to one, you got to do it to the other. No worries, Krista. No worries. So with that, we are going to move into right now, up next, looking at 2-step equations. But from right now, on a scale of 1 to 10, how are you currently feeling in terms of your confidence level with 1-step equations? Right on. Right on, right on. Sounds good. So here's what I'm going to go ahead and show you guys. I'm going to show you guys how to access this practice. And I'm actually going to put it up into the course right now. That way, at the very least, for the 1-step equations, you're going to have those, the worksheet and the video already there. So let me go ahead and check if it is there. Let me share my screen. And let's check this out here. So if we look at solving equations right over here, number 11. So for those of you that are in the program, in the Math Bootcamp course that you get, section 11 is solving equations. If you look at the video, there it is. There's your guided practice on solving 1-step equations. This is me going through a ton of different questions. So yeah, there it is. So those are the videos on solving equations, 1-step that we just did right now. Then the next little section right over here, you see that it says worksheet. The worksheet, this is where you can get plenty of practice for 1-step equations. All the way, you have 60 total problems. And what you can do is you can look at the last page for those answers. So that way you can check your work nice and easy. And so then from there, my party people, what we're going to look at is we have these videos for solving 2 steps and worksheets for 2 steps. And we're going to have more and more and more coming up. What you haven't seen yet is this. All the way down here, we have solving equations 1-step that I'm going to be plugging in again by Wednesday afternoon. So this is basically giving you a bunch of questions for you to try out over and over again. They're randomized, so you're not going to notice the same ones, and you get to practice with your mental math or on paper. So again, if you are in the program, there it is. If you're not in the program, well then, you have the opportunity to go ahead and get the program if you'd like to, but I'll talk more about that at the end of class. If you notice at the bottom left of the screen here, there's the link for you to go ahead and check out the full program if you want to take your own time during class to check it out. But it's awesome. It works. Yeah, so there it is. So with that, let's go ahead and check out these 2-step equations. Before we do that, let me go ahead. Let me bring about some easier 2-step equations because I want you to look at these for sure. but I want to make sure you guys also know how to do the other type. So either way, I feel pretty confident that you guys can tackle this. I know you guys can. So let's go ahead and let's take a look at these. Everybody, give me one word. Please keep it PG. Give me one word that you can use to describe how you feel when you see equations like this. Hey, Ron, no worries. Keep it PG. If someone told you, hey, solve these, this is not what we just did. This is not one step. This is two step. What's going on here? If you were asked to solve these, how would you describe how you feel? Keep it PG. No. Embarrassed, kind of lost. Confident, blank, I would be confused, angry, it's okay, tint, gonna not say that, feeling like Bart Simpson. Disgusting, horrible, confused. I said keep it PG, and some of y'all did not keep it PG, but that's okay. So with that, time to go home. All right, so everybody, fill in the blank. Solving equations is the art of what? It's all good. I got y'all. Don't worry. What did I say earlier? Solving equations is the art of what? Working backwards. Let's write it down one more time. Let's write it down one more time to get it through our heads. Solving equations is the art of working backwards. Right over here. And there we have it. So let's just understand again, what are the forward steps? That way we can understand what the backward steps are going to be. This is what it's always going to be about, everybody. This is what it has been about, and this is what it will be about. Look, we start off at whatever B is, right? So we'll go ahead and actually just draw an actual square here. All right, so we start off at whatever B is. And let me go ahead and highlight B. So here is B. Everybody, from what you can tell, what is happening right now? To the B, what is currently happening? Are we supposed to, if I knew what B was, would I first subtract the 10 or divide the 28? Which one should I do first? If I knew what B was. Deborah, yeah, that is a fraction, right? You see that it's B minus 10 over 28. That is a fraction. So which one should we do first, everybody? Like if we knew what B was, like for example, if I started off by just writing this as 2 minus 10 over 28. Now, I am not saying that 2 is the answer. I don't know what the answer is yet. I'm going to solve this with you. But if I knew whatever B was, everybody, what should I do first? Should I subtract 10, divide 28? Which one should I do first? What should I do first? Okay, so the majority of us are saying subtract 10, and that is true. Remember, everybody, remember this. When you're dealing with fractions, it's the entire numerator divided by the entire denominator, right? It's the entire numerator divided by the entire denominator. Yes or no? Yes or no? You do whatever the top is, divide that by whatever the bottom is. That's why you have more than one thing up top, because you're doing all of that up top. It's not like there's one fraction and then they're separate. No. You get the whole thing up top that you're doing, dividing everything on bottom. And so let me write that and show that for you. That's going to be B. Then we subtract 10. So right over there, subtract 10. And then from there, after we subtract 10, what do we do with whatever we have? After that, what do we do? What do we do after that? Yeah, after all that's said and done, then we divide by that 28. Yeah, then we divide by this entire thing right over here. Let me use a different color. But yeah, then we would divide by the entire 28 right there. And so from here, we would divide 28. And then that's how we would arrive at that -1, right? That's how we would arrive at the -1. And so the reason I wrote it like this, the reason I just showed you all the steps that we just did is because we're going to basically go outside in now. We're going to break in from the outside in to get B by itself. Notice this is 2 steps. This isn't that easy one-step stuff or the essential one-step stuff that we just did. We got to understand 2 or more steps. So with that said, everybody, let's work backwards. What's the first thing we need to do to get back all the way back to that B? What's the first thing we do? Exactly. We got to work backwards. We got to multiply 28 on both sides. Let me go ahead and make it clear to y'all. Let me go ahead and move all of this slightly over to the right. And I'm going to basically show you how we're working backwards here. So here, what I would do, I would do the opposite operation, multiply by 28. Do the opposite of the path. What do I do when I get to this step? Okay, add 10. And then I would get back to where I started. Yes or no? Do we agree with that? Do we agree with the backward steps here, with the opposites operations? Do we see it? Good, exactly. So that's really what it is. It's really just the art of working backwards. So check this out. If the first thing I do is multiply both sides by 28, look at how cool this is. Something that looks ridiculous is going to start turning into something that looks doable. Because when you multiply by 28 and divide 28, cancels out, nice and easy. And then from there, what happens? We're left with B minus 10. On that right side, everybody, what's negative 1 times 28? What's negative 1 times 28? Yeah, negative 28. That's right, negative 28. So one more time, for those of us that came in just a little later, no worries, I got you. So remember, what we're doing is we're working backwards. If we want to get the B by itself, I know the biggest question that a lot of us have is, hey, why aren't we adding 10 on both sides first? Well, the reason is because you have the entire numerator, the entire top of that fraction being divided by 28. So you have the entire top divided by 28. So before you can get to the 10, you got to get rid of that denominator. You got to get rid of that 28. And what you need to understand is that a fraction means division. This is dividing 28. So to get rid of that, you got to multiply by 28. That's why we have to do that. And so once we do that, we got rid of that 28 right there. So we have B minus 10 equals negative 28. And so once we're there, that's where we're good to go. Because we're looking at this step here and we say, hey, if we have B minus 10 and we got to get rid of that minus 10, everybody, what am I supposed to do to get rid of that minus 10? Andre, the 28 becomes negative is because you're multiplying by a negative 1 here. Remember, when you multiply by 28, you got to do it to both sides. You got to do it to both sides. And so when you multiply by that negative 1, that's how it became negative 28. Yeah, exactly. And so to get rid of that minus 10, we have to add 10 on both sides here, everybody. We got to add 10 to both sides because right here, it's going to disappear. And then from there, negative 28 plus 10, what is that, everybody? What is that? Negative 18. Negative 18. Yep. And we'll have B equals negative 18. Nice and easy. Nice and easy there. So this right over here, it's all good. This over here was really meant to show you, again, the forward steps. If you knew what B was, take away 10, then whatever you get there, divide 28. Take away 10, divide 28. But we're working backwards. And if you notice, the first step we took, times 28 on both sides. Then working backwards again, add 10 right there, second step. And so you can use that to kind of map it out, especially when you're looking at a problem that you think is absolute craziness, right? Especially if you think that this is absolute craziness. So let's go ahead and take a look at this other problem here. Hey, great, Gabriel, it's all good. So I'm going to go ahead after this next one here. I'm going to show you the more basic ones that you're going to see on the test, and I'm going to show you how to walk you through those. The reason I want to show you these is because I'm going to show you that throughout the entire class, it's always going to be about working backwards. That's what I want to prove to you today. So With that, let me go ahead and attempt to go through here. This one right here, -5 equals -6 plus r over 4. I'm actually going to go ahead and rearrange this for you to help you see this in a better way. And I'm going to work through it with you. Okay. So this is a different type of problem, but it's still, again, following the same rules. Let me rewrite it for you right here. -5 equals, and I'll just say r over 4 minus 6. Hey, Tariq, no worries. Again, this was a slightly more complicated version. So if this is confusing you, no worries, keep listening. But if anything, we're going to talk about the next set of problems that we have going on. So when we check this out here, we have -5 equals r divided by 4 minus 6.
Hey, if you'd like to watch all the classes, get all my practice problems, and text me whenever you need help with anything at all, then check out my ASVAB All-Access Program. It's everything you need to succeed. It's how my students raise their scores and get the jobs they want all day, every day. Oh yeah, and by the way, I got a master's degree in teaching, and I've been teaching for over 10 years. I put you first. I'm passionate about it. So check this out, and let's get to work. Let's ace the ASVAB.
Everybody, let's go ahead and circle the r. Let's start there. Because again, that's what we want, right? We want to figure out what r is. Now, this is a little different than the last problem, simply because I'm looking at that and we're not supposed to subtract 6 first, everybody. Because you see that -6? It's away from the fraction. It's not like it's up top with the r. It's away from the fraction. Everybody, yes or no, do you see that? Do you see how the -6 is away from the fraction? Not like this problem where it was all up top together, right? Do y'all see that? Here it's all together up top. Over here, you see that the r and the -6, that -6 is away from that fraction. So here's what we're going to say. If I knew what r was, the first thing that's happening to it is that division of 4. And then I think we can agree that the next thing that would happen, the only thing that can happen after that, is then going to be -6. Again, we're only talking about that same side of the equation here. We're only talking about the same side of the equation. So y'all, let me know if that makes sense here. We have the r that we're looking for. If we're working forward, we're dividing by that 4. And then the last thing we would do is subtract 6. Because if you can understand what's going on in the forward sense, now we can understand what's happening working backwards. So we would go ahead and add 6 to both sides first. That's right, Armani. Exactly. It's because the -6, taking away 6 is the last thing that's happening. So that's the first thing we should take care of. -6 is the last thing that's happening. So that's the first thing we're going to take care of. And the way that we take care of that is by taking that away from both sides, or adding 6 to both sides, excuse me. Because once we do that, -6 and +6 cancels out. You did the backward step, so it reverses it. And so when you take a look here now, we're going to have r over 4 equals whatever -5 plus 6 is. Everybody, -5 plus 6 is the same as 6 minus 5. What is that? Right, that's going to be +1. And now while we're here, well, what's the backwards step of saying r over 4? Over 4 is divided by 4. So what's the backwards step there? That's right, Harley. Yep, that's right, Armani, Marie, Simone. Yeah, we multiply by 4. We would exactly multiply by 4 here. Bam and bam. And on the right side, that's going to cancel out. That's going to cancel out, leaving us with whatever 4 times 1 is. R equals 4. Okay. And there is that. There is that. So on a scale of 1 to 10, how much sense were you able to get from this problem? Where a 5, I would say, is, man, I understood that I was working backwards, but this looks like a really confusing problem. That's where a 5 would be. And then lower than that would obviously be less than that. Above that would be more than that. All right, right on. So here's the thing about party people. The thing is, very, 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 very likely that you'll see a problem like this in solving equations on the ASVAB. Very likely. Now, you want to know how to handle something like that. You want to. You absolutely do. And so I wanted to show you that here first. And now what I'm going to do next is I want to show you the more manageable ones. All right. I want to show you the more manageable ones. So allow me to go ahead and get here. And is this two-step or that's multi-step? Let me go ahead and go to part B. And these are two-step equations. Okay. So these are some of the ones that I filmed today earlier, and I'm going to go ahead and actually show you some of the easier ones here. So let me go ahead and pull up something that I know we can go ahead and kind of relax and simmer into. So I'll take something that is undeniably we can have fun with. So I'll go ahead and take this one right over here. So let's go and take a look at this one here. -9 equals 9n plus 9. All right, let's take a look here. It's all good, Rashad. Yeah, man, practice makes perfect. Practice absolutely makes perfect. So let's check this out. We have -9 equals 9n plus 9. So already you might be looking at this like, yo, what you mean, all these nines? It's all good. If I'm checking this out, everybody, we want to get what letter by itself? Hit me. What are we trying to get by itself? Right, we're trying to get n by itself. We're trying to get n by itself. Let's go ahead and just understand where that is. Remember, to solve this, you got to be able to work backwards. You got to be able to work backwards. So what's the last thing that's happening? Well, to figure that out, you got to understand that with PEMDAS, order of operations, you would basically have multiplication first with the 9, and then you would add that other 9 at the end. So to work backwards, what I got to do to get rid of that plus 9, everybody, what do we do to get rid of adding 9? Right, we would have to subtract 9. If we're trying to get into that box, if we're trying to break that box up, we would have to first take away 9 on both sides. And so what we have over here, everybody, -9 minus 9, that's not going to be 0. What's that supposed to be? If you're already at -9 and then you take away 9 more, where are we at? Where are we at? -18. Not positive 18, -18. -18. So we have -18 equals 9n. And from here, we have to ask ourselves, well, that 9 is being multiplied to the n. So what's the backward step? Yeah, we would divide. We would divide. Exactly. We would divide. So divide both sides by 9. And what we get there is going to be canceling on the right side here. And we get n equals 18 divided by 9 is 2. And a negative divided by a positive is a negative. Right there. It is a negative. So everybody, how do we feel about this one? Yes or no? Just a simple yes or no. Feel good about this one or bad about this one? Because we're going to go through more like this one. More where it's not fractions, because I know fractions are the hardest to deal with. But I wanted to open it up with it because I want you to know what to expect. So Gabriel, great question. When do we know when to divide? Well, the thing is, remember that solving equations, again, what you're doing is the opposite operations. So if you're trying to get rid of the 9 right here being multiplied, the opposite of 9 being multiplied is 9 being divided. So remember, addition and subtraction are the opposites. Multiplication and division, those are opposites. And later on, you'll see that when you're dealing with square roots and squares, those are opposites too, but you don't really need to know that for this right here. You don't need to know that. Yeah, and Deborah, where I got the -9, again, that's the opposite right here. -9 is the opposite of adding 9. So again, all I've been doing this whole time is working backwards. So if you still have questions on this, don't worry, because I'm going to go into a problem where we don't have all of them being 9, right? Let me go ahead and show you a different one here where we can probably get a better and more manageable situation. Let's take a look at number 1. Move that over here and zoom on in to number 1. Okay. So let's understand this again. Let's work backwards. Let's understand this start to finish. We have 81 equals 4a plus 9. Everybody, think of it like this. I want to get the a right here by itself. 1 second. Let me reconnect my pen. For some reason, this thing doesn't want to work for me right now. Come on. Pick the grade data. There we go. Perfect. All right. So with that, let's go ahead and take a look at it again. What do we want to get by itself? We said it. We want to get the a by itself. Right here. Want to get a by itself. All right. What's happening immediately to the 4 or to the a? The 4. And then the last thing that you have, look, the last thing that's by itself right there is that plus 9. I can get rid of that plus 9. Everybody, what's the opposite of adding 9? Especially, this is a question, especially for those that were confused in the last problem. What is the opposite step of adding 9? It's going to be subtracting 9. And where are we subtracting 9, everybody? Both sides. We're subtracting it from both sides. So if I write this over here, we got 81 equals 4a plus 9. And what we'll do is we'll take 9 away from both sides so we can get this by itself. So we can get that by itself. So it's going to cancel right here on the right side. 81 minus 9 is 72, right? And so we have 72 equals 4a. Everybody, what's the last step that we should be taking? What's the last step that we should be taking? Exactly. Divide both sides by the 4. Divide both sides by that 4, and we're good. And we're good. Because once we do that, it's going to cancel right here, leaving you with a equals whatever 72 divided by 4 is. And so if you need to go on and work on that on the side, sure, go ahead. 4 goes into 72. Let's find out. 4 goes into 7 once. Then you have the 32. And then 4 goes into 32 8 times. And so that would be 18. And so a equals 18. And so a equals 18. So are some of us thinking that this one is easier than those fraction problems that we saw earlier? Who is seeing these as easier? Okay, sounds good. So just wanted to help you appreciate what's going on here, because if we were to dive into these and make the progressions of the fraction ones, a lot of the times you guys get way too intimidated, but I wanted to actually just get that intimidation out of the way now. That way we can build back up to it to show you what your expectation is. So let me go ahead and give you a list of problems here, because I don't want to send you this way yet. So I'm going to go ahead and give you a list of problems right over here that we're going to work on together after a short timer. I'm going to give you 6 questions, and out of them, I really just want you to get at least 1 or 2 done. But I'm going to give you a list of 6. I want you to try them out, and then we'll go over all 6. So here we go. So go ahead. There's your timer. I'm going to mute myself, and I'm going to get out of your way. I'm going to give you some quiet time. Try it out. Number 1, let me go ahead and do this here. Just move this over down here to the side. Let's take care of number 1. So with number 1 here, my party people, we're taking a look and we're saying, yo, we got 3x plus 5 equals positive 23. So what I'm going to do is, well, check out what's going forward. And that way I can spot how to work backwards. So with that, you know that it's 3x, that's attached, right? The 3 and the x are together. And then you have that plus 5 at the end. So what that tells me, and again, notice I'm talking in less math terms, but more English terms. We have the 3 and the x, those are attached together, but we have plus 5 by itself. So that's the first thing I'm going to take care of, because it's on the same side of the equation. It's on the same side of the equation. Everybody, what's the opposite of adding 5? How do we work backwards from that? Hit me. Come on. There we go, Armani, Sunny. Yep. But we're all forgetting the same phrase from both sides because you guys are lazy. So I'm kidding. So here we're supposed to say subtract 5 on both sides. That's right. So from there, let's go ahead and take care of that and let Naya in. So minus 5. And once we do that, we end up getting that cancellation right there. Adding and subtracting 5 cancels out. And we get 3x equals what? We get 3x equals 18. All right, cool. So now that we're at this part of the story, 3x equals 18. Everybody, what operation is currently happening between the 3 and the x? What operation is currently happening between the 3 and the x? Right, multiplication. And so the opposite of multiplying by 3, divide by 3. Right, divide 3 on both sides. Make sure to say that correctly. So we'll divide by 3 on both sides. And once we do that, that cancels out here on the left, giving you x equals 6. So for those of us that tried number 1 out, did we get 6? Did we get 6? There we go. There we go. That's what I love seeing. Okay, let's go ahead and try out this next one here, number 2. So let's bring that in. Let's bring in number 2. So number 2, we have 5x minus 3 equals 97. So again, we're trying to get that x by itself, but we see that we have a 5 attached to it. And then you have that minus 3 by itself. So I want to get rid of that minus 3. Everybody, how do I get rid of the minus 3? By doing what to both sides? Right, we add 3 on both sides to get rid of that. Exactly. So once we do that, if we add 3 to both sides, we end up getting what? So that's going to go ahead, cancel out, leaving us with 5x equals 97 plus 3. That's going to be 100. Okay, now what's up next here? What do we need to do? Man, y'all really love shorthand today. Divide what? Divide 5 where? Armani, appreciate you being, there you go. Yep, divide 5 on both sides. There we go. I'm going to be annoying. You'll thank me later. Divide by 5 on both sides. And that's going to cancel out here on the left. And we get ourselves x equals 20. So if we got 20 for number 2, great job. And if you didn't, remember the opportunity here is the growth where you're saying, hey, what did I do incorrectly? What should I have done? And why is that what I should have done? Right there. What did I do wrong? What should I have done? And why is it that I should have done that? Because it's not just about knowing what happened, it's about why it happened. Because the questions that you can find for solving equations, there's an unlimited number of them. Very unlikely that you get the same one twice. But it's very likely, it's actually guaranteed that the reasons that you take, the steps that you take, those reasons are going to be the same every single time. So here we go, number 3. Number 3, we have 12x minus 3 equals negative 15. Let me just move this up here. So 12x minus 3 equals negative 15. Let me move this down a little bit, move that down a little bit. There we go. So let's take care of business here. We are looking at 12x minus 3 equals negative 15. You might be looking at that negative 15 like, oh no, it's just a number, just a number. If you don't know how to handle negatives, again, we got to work on that. But we see that we have the 12x, and then there's that minus 3 all right there. So to get rid of a minus 3, that's right, you guys already got it down. There it is. Add 3 to both sides, nice and easy. Once that happens, that cancels out because subtracting 3 and adding 3, opposite operations. And so here we have the 12x left over by itself. And then negative 15 plus 3, what's that going to be? Yeah, negative 12. Remember, when you have a negative and a positive being added together, just subtract the numbers and keep the sign of the bigger number. 15 minus 3 is 12. but it's going to be negative 12 because that 15 is way bigger than 3. And so now that we're here, what do we do to both sides? Not divide negative 12, but divide by 12. Yeah, divide by 12 on both sides. Remember, it's opposite operations, not opposite signs, opposite operations. So we're going to divide both sides by 12. And so from there, boom, we cancel out the 12 and we have ourselves x equals negative 12 divided by 12, which is negative 1. Negative 1 right there. So who here is 3 for 3 so far? Who here is 3 for 3 so far, man? It's good to see. It's good to see, guys. I love it. I love it. I love it. Let me go ahead and get number 4 set up for you. So let me go ahead and move that all the way up there. Let me go and cut this. Actually, I'll just move it down here. All right, here we go. Negative 3x plus 10 equals negative 11. So the first step that you'll take here, I'm going to speed up the process just a little bit. Take away 10 on both sides. And that's going to go ahead and cancel right there, giving you negative 3x equals negative 21. And so from here, then you're going to go ahead and get rid of that negative 3. Not by adding 3, but by dividing by negative 3. Remember, what's happening is multiplication. You are multiplying these terms together. So you need to divide to get rid of it. You got to divide by negative 3. And so remember, you're dividing by negative 3. What that tells you is that you have a negative and a negative canceling out. Same thing here. A negative divided by a negative is a positive, and your answer will be x equals positive 7. Not negative 7, okay? If you got negative 7, do you see why it's actually positive 7? That's one of the big questions I got to ask here. If you got negative 7, do you understand why it's actually supposed to be positive 7? Can you identify those mistakes? Sonny messed up on the negative 11 minus 10. It's all good. Again, we make those mistakes, but we can correct them. Okay, let's go ahead and get into number 5 here. Number 5, then number 6. So these are probably a little more confusing. Yes or no? Do you agree that numbers 5 and 6 are a little more confusing than the other ones that we just saw? Armani got too happy there. No worries. Okay, no worries. If you didn't get the chance to try it, it's all good. I got you. So let's go ahead. Let's get to it. Number 5, we have 8 minus 10x equals 58. Okay. If I were to just go ahead and say it straight up, if I were to just say straight up, yo, the first step is going to be subtract 8 on both sides. Yes or no? Would that make sense to you? If I were to just say straight up, first step, subtract 8 on both sides, would that make sense to you? Okay, good. Now, for those of us that are thinking, yeah, I'm not sure, man, this looks a little different than the last problem. I'm not really sure what's going on. Everybody, I want to make sure that we all understand the following. And I'm not saying this is a joke. I'm saying this like in the real sense. Everybody, 1 plus 2 is the same as 2 plus 1, right? 1 plus 2 is the same as 2 plus 1, right? Right? I think we can agree on that. So when you're looking at 8 minus 10x equals 58, this is just like the other problems that we've just been doing, just like them. Because the thing is, you can rewrite 8 minus 10x. That's literally the same thing as saying negative 10x plus 8. All I did was just I made sure to bring the sign with me. I just moved it to the front, but it's literally the same thing. Yeah, you can definitely move it around. 1 plus 2 is the same as 2 plus 1, right? 5 plus 10 is the same as 10 plus 5. You can rearrange it. Just bring the sign with you. You're good. Just bring the sign of the number with you. You're good. You can absolutely move it around. When you have terms that are separated like that, you're adding and subtracting them. So yeah, you can absolutely move it around. Yeah, Lewis, for sure. Yeah. It's the same thing. All I'm doing here is to show you that that +8 is the first thing you'll take care of. You don't see the plus there from the beginning because the thing is, when we say 5, we mean +5, not -5. If we just say a number like 10, we mean +10. If I say 50, I still mean +50. So for us to be able to see that this is 8 being added, a lot of us need to see that, yeah, it's like this. But in case you didn't see it that way, it doesn't matter because all you got to do is start off by taking out that 8, subtracting 8 on both sides. It is not a -8. Deborah, no. It's not 10x minus 8 because the negative, you see right here, the negative is with the 10, the 10x. The negative is not with the 8, the negative is with the 10x. So that's why you move the negative with 10x. Billy, there's a good shot, especially if you're taking the computer version, that you will have a one-step in there. But if you want to score anything higher than a 40, you got to know how to do two-step equations. Definitely. So here, if you want to pass too, you should be able to do two-step equations actually. So with that here, yep, we're going to subtract 8 on both sides to give us -10x. This cancels here. And 58 minus 8, everybody, is what? 58 minus 8 is 50. Okay, great. And so from here, our last step is going to be what, everybody? What's the last step going to be? Amber, appreciate you. Appreciate you there. Yeah, divide -10 on both sides. Thank you, Armani, Pedro, Christian, Shaylee. Yep, divide -10. Be careful there, Christian. -10, David, -10, -10. We want to divide the -10 on both sides. And so from there, oh, no worries, Carrie, my bad, I must have missed that. But, oh, you must have been saying the answer. And so with that, we have -10 canceling out. And 50 divided by -10 gives us what? Well, that's going to be -5. X equals -5. And then the last one, let's go ahead and take care of business here. This last one we have going on is right over here. Take a picture if you need to. Take a picture if you need to. Let me get rid of that timer. Oh, yeah. And then here, number 6. Last one here. So I'm not even going to rearrange this one. I'm going to leave this one as is. Everybody, what am I trying to get rid of first? The 50 or the -4? What am I trying to get rid of first? Yeah, everybody, we're trying to get rid of that 50 first. It's the furthest thing away from the x. Right now, that -4, it's hugging the x. It's hugging the x. The 50 is by itself. So, think about if you're trying to go ahead and, if you're a lion trying to hunt a gazelle, you want to go for the one that's away from the pack, that's unaware, that's not safe. So get rid of the one that's away from everything first. So here we have that 50 just sitting there. So I'll subtract 50 on both sides. And from there, that gets canceled out, nice and easy. Everybody, what's 22 minus 50? What's 22 minus 50? You remember 22 minus 50 is the same thing as 50 minus 22. It's just a negative version. It's just a negative version. Yeah. Once you do the math, it's going to be 28. -28. So we have -4x equals -28 here. Yeah, iPhone or Justin. Yeah, that's going to be 50 minus 22, but the negative version of it because you're subtracting way more than what you have. If it was 50 minus 22, that would be 28. 22 minus 50, -28, excuse me. And so my last step here is going to be to go ahead and divide by -4 on both sides. And so once we do that, my party people, once we divide both sides by -4, that's going to cancel out on the left with the negatives. The 4s also cancel. And so that gives you x equals, and on the right side, negative divided by negative is a positive. And 28 divided by 4 is 7. And there you have it. 6 for 6, Simone. Love seeing it. Love seeing it. There we go. There we go, man. Boom. And even if you missed one or two or three, the point of this is to grow from it, not to see exactly where you are. You know, if you wanted to see exactly where you are, go take a practice test. If you want to grow, then get the practice in and analyze every mistake so you make those mistakes less. Remember, everybody, it's not always going to be a light switch. A lot of the times it's more like pushing something heavy from one end of a park to the other end. You got to keep putting that consistent effort until it becomes easier and you're done. So let's go ahead here and let's go back to looking at those pretty insane examples that we thought were insane earlier. So let me look for one that I know would be easy on the eyes before we get into the other ones. Okay. So everybody, looking back at this again, are you as nervous as you were before, more nervous, less nervous? How are you feeling about this one? Are you just as nervous as you were before, less nervous, more nervous? No, I'm good. All right, so, hey, Billy, it takes practice, man. It takes practice. All right, so let's go ahead and try this here. We have n minus 8 over here. So I'm going to write this n minus 8 over 22 equals -1. So everybody, let's just go ahead and take a look at this in English, man. In English. Let's look at this in English. I see that we have the n minus 8. Everybody, yes or no? Is the n minus 8, is all of it being divided by 22? Or is it just the n or just the -8? Or is it the entire n minus 8? Yeah, it's the entire n minus 8. Everybody remember, when it comes to dealing with fractions, you have the entire numerator divided by the denominator. You have the entire numerator divided by the denominator. And so because of that, you have the entire thing divided by the 22 here. You have the entire n minus 8 divided by 22. So the first thing we need to take care of is that 22. Everybody, what should we do to both sides? Armani, that's right. Elon, that's right. That's right. Multiply that 22 on both sides. So that's why I'm going to go ahead and multiply by 22 over here and multiply by 22 over there. All right, that's what's happening here. And so with that said, Andre, my man, go ahead and pay attention here because I know you're having a little bit of trouble with negatives. I got you, Andre. So here, the 22 and then the 22 on bottom, you're multiplying 22 and dividing 22, so that's what cancels it out. But let's understand how we get the right side here. So notice over here, we got -1. Let me make sure I highlight that. -1 times 22. Everybody, a negative times a positive is what? Negative. Yep, exactly. A negative times a positive is a negative. And then 1 times 22 is 22. Exactly. And so from here, now what we'll do is we'll go ahead and get that n by itself by adding 8 to both sides. And so then from there, everybody, what is -22 plus 8? Remember, you have a negative plus a positive, so just subtract the numbers. 22 minus 8, that's 14. But that should be a negative because that 22 is the bigger number. So that should be -14. So everybody, are we feeling better or worse than we did before? Again, dealing with the same exact problem or type of problem. Are we feeling better or worse? That's what's up, Tariq. I'm telling you, once you keep putting in that effort, man, it gets better and better and better. And notice how we're looking at different types of problems here. I'm not trying to force you to memorize anything. I want you to understand every decision you make. Understand every decision you make. Don't just be like, oh yeah, I memorized this. You multiply what was in the bottom and you do, no. Understand it. Understand it. Understand it. So let's go and put up another one here. I'm going to put up one that's similar to that one. And I want you guys to try it out. So here we go. This one right here, number 23. I want to give you guys about a minute and a half to try this one out. Here we, where'd my timer go? There it is. A minute and a half here. Go ahead, try it out, and we'll be right back to go ahead and check the answers. One equals x plus 1 over 18. I'm looking at this and I'm going to rewrite it. I'm looking at this and what we see is that, hey, look, we have the entire x plus 1 here divided by the 18. So I want to get rid of that 18 and I know it's being divided. The opposite is multiply the 18. So when we do that, that gets canceled out. And then we have 18 times 1. 18 times 1 is 18. And that's going to equal the x plus 1. And so from here, the last thing we'll do is we say, hey, I need to go ahead and subtract 1 from both sides. Nice and easy. And once I do that, booyah, you see that the answer is 17 equals x. Boom. So who here got that right confidently, man? That's what I like to see. That's what I like to see. So let's go ahead and now go to the other type of fraction example that we saw earlier. This is one type of fraction example where we have the entire numerator divided by something. Now here's another fraction example where we're actually going to have to, like right over here, 10 plus k over 4 equals 12. This is a little different because notice how that 10 is not with that fraction. So in this one, you see that we have the whole k plus 4. So the first step you should take is to get rid of that 10. So one more time, I'm going to give you a minute and a half. Well, for this one, I'm going to give you 2 minutes. And I want you to really, again, try this out here. Right there, 2 minutes. Go ahead and try it out here. And again, get as far as you can. I don't expect you to get it all done in one sweep in 2 minutes. I guess get as far as you can, making sure that you're confident about every step. Armani, what? All I gotta say is my whole house gets so tempted. Hey, these comments, I love it. All right, go ahead, guys, give it a shot. I'll be right back. So remember, everybody, I want to make sure we understand what is going on so we know what steps to take. So we have 10 plus k over 4 equals 12. Notice that you always want to start off with whatever is basically separated from the variable. You want to start off with what's the furthest thing away from the variable. That's in English. In math talk, in simple math talk, you want to start by working backwards from the last step that you would take with the order of operations. So basically, you're looking at the k, it's being divided by 4, and then you got that 10 by itself just chilling. So I want to take care of that 10 first because there's nothing stopping me from getting rid of it first. Nothing stopping me at all. So what I'm going to do is I'm going to subtract 10 on both sides to start off to get rid of that 10. So when I do that, booyah, that gets canceled out. And so I get k over 4 equals 12 minus 2. Man, that's hard. 2. Yep. And so then from there, we have k divided by 4 equals 2. So to work backwards and get k, if I'm dividing by 4 to get 2, I'm going to multiply both sides by 4 to get back to the beginning. So here, multiply by 4, and booyah, there we go. That cancels out on the left, and we get ourselves k equals 8. Nice and easy. Pedro, I got you. Tariq, I got you, man. I'm telling you, this is really what it's all about, man. We got to make sure we practice to the point where we can explain every step, but work without even thinking. Like it is possible. It does take time, but it is absolutely possible. And so one more time, everybody, I'm going to give you one more problem. I'm not going to explain it, but I'm just going to give you the answer after the fact. And I'm going to explain what the next steps are in terms of making sure that you're good with this practice. So try number 24 out. I'm going to go ahead and give you again another 2 minutes here to try it out. I'll give you the answer, but not the work. And then I'm going to tell you what the next steps are. So here we go. And we get this timer up. And if you are also interested in the program, just stick around to the end of class. I'll go ahead and give you the link and a discount code so you can sign up.
In case you haven't heard, I have an ASVAB program that's meant to help you raise your score wherever you're at. And here are 3 great reasons to go ahead and consider it right now. 1, you get all of my classes. 2, you can text me whenever you need help. And 3, you can't beat the price. I can promise you right now, if you click the link in the description of this video or somewhere around here, and you go ahead, watch how it works and look at the price, I'm pretty sure your jaw's gonna drop. It's actually 24 hours of classes a month plus everything else that you get with it for less than $60. So with that said, go ahead and check it out. I'm Anderson, your ASVAB coach, and I'm proud to help you ace the ASVAB. Let's get to it so we can get that job we deserve. Check it out now. But until then, if you say no, it's all good. Let's get back to the learning here and let's keep crushing it.
What we're gonna do is the following. Here's the work to get the answer. And in case you didn't know, the answer is 15. But what you're gonna do is you're gonna subtract 7 on both sides. Then you got x over 5 equals 3. Then we multiply both sides by 5 and we are good. I know I went super fast there, but I got to make sure I give you guys the directions on what to do coming up next. So take a quick picture of that if you'd like to go ahead and get that in there. But now I'm going to go ahead and again speak to the effect of, hey, we just went over solving equations, 1-step, 2-step, 2-step with fractions. And so now we need to look forward to how much better we can get and what we can do to really guarantee that we're confident on test day. So this was 2-step equations. That's right. This was 2-step equations. So this felt way too easy. Hey, don't worry. There's other types of multi-step. There's multi-step as well, where you have variables on both sides, where you got parentheses and craziness going on about.